Okay, today we're going to be talking about trapezoids. Trapezoids is another one of the quadrilaterals that we're going to be studying. Okay, and we're going to start with the definition. We're going to have a trapezoid. And a trapezoid is a quadrilateral with one pair of parallel sides. Okay, so a drawing of that. We would have a four-sided figure and only one pair of the sides would be parallel. Okay? We also have an isosceles trapezoid. Okay, an isosceles trapezoid is a trapezoid, meaning that it has one pair of parallel sides, with the non-parallel sides congruent. Okay, so an isosceles trapezoid is a trapezoid with the non-parallel sides congruent. So typically they have the same setup as a trapezoid. Here are my parallel sides, except this time these non-parallel sides are congruent. So these two sides would be congruent. Okay. The next thing I need to go over with you is called a mid-segment. And just as the name implies, it's a segment in the middle. It's a segment located sorry about the technical difficulty, in the middle of a trapezoid. I don't know if I'm going to squeeze it in there, or triangle. It does have a formula. So the formula for a trapezoid is equal to 1/2 times base 1 plus base 2. And if I have my trapezoid here, my mid-segment would go right through the middle of it, making this piece equal to this piece because it has to be in the middle, and this piece equal to the other piece. Especially if it's not an isosceles trapezoid, you would have the two different markings because the sides would be two different lengths. Okay, then we have the mid-segment for a triangle, which is just 1/2 the base. So in my triangle, my mid-segment would be right through the middle. And again, this side would be split into two equal pieces, and this side would be split into two equal pieces. Okay, let's fill in our property sheet. Okay, so in our properties, we should have everything filled in. All of our squares have all of theirs filled in. So we really just have the trapezoid and the isosceles trapezoid that's left. And we want to look at those properties. For a trapezoid, are the opposite sides congruent? No, not typically. They might be, but not in a regular not in a trapezoid. Adjacent sides are congruent? No. Opposite angles are congruent? No. Adjacent angles are congruent? No. Are the diagonals equal? No. Do they bisect each other? No. Are the diagonals perpendicular? No. So pretty much nothing happens with the trapezoid. Now in an isosceles trapezoid, typically are the opposite sides congruent? No, but you do have one pair. You do have one pair, and they're the non-parallel sides. Are the adjacent sides congruent? No. Are the opposite angles congruent? No. Are the adjacent angles congruent? Not typically, but your base angles are congruent, and your same side interior angles are supplementary. Okay? You do have base angles congruent, and your same side interior angles are supplementary. Are the diagonals equal? Yes, they are in an isosceles trapezoid. Do they bisect each other? No. Do they meet at a 90-degree angle? No. And that ends our properties on trapezoids.